Hi all, welcome back. Today we're gonna see numerical methods. Actually, this is the last syllabus and we're gonna start this. I think numerical methods will take up to 3 videos because it is a shortest syllabus actually. So, what is numerical methods? Normally, numerical methods are used to find the higher order equation, because normally we are using the analytical method. So it will give exact values, like if I say x cube plus x square, likewise means we will get the roots exactly 5, 6, 7 like that. Okay, so analytical method will give the exact values of x, but here for higher order equations, whatever may be the thing, numerical methods are used. Okay, but this method do not give exact values, actually it give approximate values. Okay, so for that, to find the solutions, there are 4 categories here, like 4 methods: differential equation, integration of function, okay, differential, integration, and then system of linear equation, and algebraic and transcendental solution. Transcendental solution, okay, algebraic transcendental solution. So first one we're going to see that algebraic equation, which is in the form of polynomials. Okay, it contains many things. Okay, like f of x, which is equal to a naught into x power n plus a1 into x power n minus 1 plus up to a n minus 1 into x plus a n, which is equal to 0. So it contains many terms and it's a polynomial. Okay, so this is the form for algebraic equation, like x power 4 plus 3x square x cube plus 1x square, like that. Okay, 1 or 2 plus 4x minus 3, which is equal to 0. So this is called algebraic equation, and it contains polynomial. The n may be a, like the this is x power 4, right? It can be x power n. So this is the form. Transcendental equation, combination of polynomials, exponential, and trigonometrical function. You know, trigonometrical function means cosine, sine, tan, it will include these things. Exponential means e power x, like that. Polynomials means like this, x square, x power cube. Okay, so it will contain all the things. Example, they have said tan x, x into e power x, cos x minus x into e power x. Okay, and the first theorem we're gonna see is intermediate value theorem. If f of x is constant function, so f of x is a constant function defined in this interval, and the f of a function and f of b function which will have the opposite signs. If it is have the opposite signs, means then there exists at least one root in between this interval. Okay, if f of a and f of b has different signs, okay, then we can easily say that any one root from f of x equation, any one root should be inside ab. So they have given one graph here, a point, b point, this is the root. Okay, so this is a function and it is b function. For example, if I gave f of x as this function, means if I put the interval will be 0 to 1. If I put f of 0 like f of a and this is f of b, right? So f of a means it will be less than 0. F of 1 means it is greater than 0. You can see here, so 0 to 1. So this root includes in this thing. But here this is the opposite sign. it has less than and greater than, right? So it has opposite signs. Okay, like this means if the two functions are in opposite signs means any one root should be included in the intervals. Next one, iterative method, successive approximation. Okay, express f of x which is equal to 0 as x equal to pi of x. I need to say like x is also a function. Okay, so express f of x is equal to 0 as x is also a function here. Actually, choose an initial approximation to the root in the given interval. So we need to first initial approximation, like we need to first find x naught here to the root in the given interval. Okay, next find the next approximation using x1, x2 of these function. Just we need to find initial approximation. After that, for finding x1, I need to substitute this x naught in the f of x function. Again, this x1 in the f of x function, and I will get x2 equal to this one. So we need to substitute till the end. So we can find x1, x2, x3, x4. For example, I need x5 means I need to substitute x4 in this function. That's it. So this is the thing here. Then find the next approximation using this function. So okay, stop the iteration if two consecutive iterations gives the same approximation. So here we need to stop the iteration when two executive iteration gives the same approximation. For example, x3 is 4 and x4 is also 4 means we need to stop up to this, or 4.23, 4.23, the same approximation. It should give the same approximation, so we need to stop up to this. Next one, the sequence of approximations converges to the root if del, like modulus of the first derivative of this function should be less than 1. Just think modulus. Why we need modulus? Because it can be positive or negative. So we need only positive. So modulus. Okay. And the first derivative. So modulus of the first derivative of function should be less than 1. This is the thing. So sequence of approximation converges to the root if, so this sequence of approximation converges means it will come to an end to the root if this condition. Okay, you can easily understand those statements if you see the sum. Okay, so they have given x cube plus x plus minus 1 which is equal to 0. So from these things we can find the x by 3 things. You can see here, this is the equation actually. I am just bringing this 1 here, and then I can easily write x which is equal to 1 minus x cube, right? So this is one form. And then again x cube which is equal to this 1 minus x. So 1 minus x. I am just bringing these 2 terms here. After that I am just taking cube root here. So this is another form. And the third form, I am just taking x as outside, and you can easily form this as a third one. Okay. So from this thing, first just take this as pi of x, like this, another function like f of x. Okay. So you need to take this x as a function here, which is equal to 1 minus x cube. So this is the form. After that, just differentiate first derivative in the modulus. So we can easily get only the positive values, right? So after that, just do all these things same. Just take this term as pi of x. Okay, like this term as pi of x. Just bring x in the left hand side, and remaining part will be the pi of x. Okay, so you can see here x into x square plus 1. So this will come down, right? So 1 by x square plus 1. So these are the functions and these are the first derivatives with modulus. Okay, so you can easily get only positive here. Okay, next one. So they have given the interval 0, 1, right? So I am just putting 0 here and 1 here. If I put 0 in the pi of x, I will get only, in the pi dash of x. Okay, if I put 0 in the pi dash of x, I will get only 0. So it is less than 1 and greater than 1. Same appears here. It is less than 1 and it is infinity. So just remove or don't consider these two things. And you can see here the both are less than 1. So modulus is less than 1 here for both the roots, for both the intervals. Okay, so we can easily, this is what the sequence. Okay, so this is what the sequence of approximation. So sequence of approximation. Okay, next the iterative method. So the iterative method, so this method x equal to 1 and x equal to 0. You can see here I am just applying x equal to 1, x equal to 0 and 1. And you can apply up to x equal to 22. This is called iterative method. Just bring this 1 and substitute here, and again what is the value, and bring it and substitute in the function. You will get up to the end. Next form, bisection method. Suppose that a root of f of x which is equal to 0 lies in the interval. So we have said the root of f of x is already 0 and it is in the interval a0 b0, means f of a0 into f of b0 should be less than 0 because it has opposite signs, right? So one positive into one negative will give always the opposite sign, like minus negative, which is always less than 0. So this is the thing here. If f of x which is equal to 0 means the both function, the function which includes the interval should be less than 0 because one is positive and negative. So we will always get less than 0 here. Bisect the interval to obtain C1. So first we need to obtain C1. This is what the center of the two intervals, center point. So A0 and B0, right? So this is what the center point. Okay. So for finding this, just plus add this one by 2, right? It's like a mean. Roots lies in intervals I1. So we can easily say the roots may lies between A0 to C1 or C1 to B1, right? If the roots or lies in the first interval means we can easily say the first thing, f of A0 into f of C1 which is less than 0. If it is not less than 0 means we can take the second interval. Okay, and then we need to repeat it to the n times so that the root given by the midpoint of interval, so that we have got the root. Okay, so we need to repeat it. For example, they have said x cube plus x minus 1 which is equal to 0. This is a f of x function. They have given the roots. First we need to find the C1. C1 means 0 plus 1 by 2, so half. Just substitute C1 and 0 here. And you can easily see both are negative, right? If negative into negative, it will be positive. So it is greater than 0. So the first condition is fails. So I can easily take C1 comma B0. This is the interval. Again, we need to find it. C1, C2. We need to check up to the end we have got the roots. So for example, in the exams they will ask up to 2 terms. Okay, so they will given the they will give a conditions here. So in the question itself they will give some conditions. So up to 2 terms, up to 3 terms. So up to that we will find that. Okay. C2 which is equal to 0.5 plus 1 because these are the new intervals. So we have found it, and then again it is greater than 0. So again we need to take the other two things, other intervals. So it will go on up to C12. So we have got the last intervals. You can see here it is almost the same. Okay. So next method, regular Falsi method. Okay, regular Falsi method or method of false position. Assume two initial approximation. So first we know that this is what the initial approximation. I am just assuming two things here, x0 and x1, such that f of x0 and f of x1 is less than 0. So they are giving the conditions here. Find the next approximations using x into k plus 1. So x k plus 1 which is equal to x into k minus 1 into f of x minus k x k into f of k minus 1. Actually this seems like u dash v minus u v dash. So in terms of dash we need negative form like k minus 1. In terms of a single term it will be a positive one like k. Just bring x, f, that's it. So we can see here, if I put x as u means the next term x will be the positive one. So you can easily remember like this, and the last just minus or subtract the two functions and you will get the form. Roots lies in x0 and x1 means the condition should follow this one like in both terms, but here x2, so function of x0 into function of x2 should be less than 1, or otherwise we can easily take, just replace this x0 by x2. Okay, and continue the process until desired accuracy is achieved. If f of x in the interval in this, for simplicity just select x0 which is equal to a, x1 which is equal to a. So they are just replacing this term as ab. So we can easily get xn plus 1 which is equal to a into f of b minus b into f of a by f of b minus a, upper limit minus lower limit. So we have got the formula again. Okay, so this is what the final formula. They have given the functions here. What is the formula? X n plus 1 which is equal to a into f of b minus b into f of a. F of b minus f of a. Just substitute all the values. Just substitute 0, 1, you will get f of a, b. Okay, so you have got half. And if you multiply these two things means it came as less than 0. So the new interval, we have got the new interval here, and again we need to find it, and you will get the value as x1. So it will go on. So they may ask up to 2 terms or up to 3 terms likewise. Okay. Another way, fix one end of interval say b of f of b which is greater than 0. So I am just fixing the one end which is greater than 0, and apply iteration formula to find the new value for another end of the interval. So we can easily find the another end a itself gives the root. These two things helps to give the roots. Second method or Chord method. Chord. It is same as regular Falsi method. Sorry, it is a Regula. Okay. Regular Falsi method. The only difference is while selecting initial approximation, we don't need to consider this condition. So this is the only condition in the second method. So this method may or may not converge. If it converges, it converges faster than the Falsi method. Next method, this is very important actually, Newton-Raphson method. The iterative formula in the Newton-Raphson is f of x by f dash of x, x bar n minus. So if I say x1 means I can easily say x0 because n plus 1 is 1. So n will be n minus 1, 1 minus 1, which is x0, minus f of x function x0 divided by f dash of x0. So if you know x0 means we can easily find the all values of iterations. Initially assume x0. So I'm just assuming the x0. Newton-Raphson method fails if f first derivative which is equal to 0. If f dash of x is very large, then the roots can be found very rapidly. And there comes the conditions for the convergence of Newton's Raphson method. Actually, f of x into f double dash of x, like x0 and x2 I think. Okay, so x0 into x2, the whole modulus should be less than x1 modulus square. Next, the example here, they have given the example. First find f of x, f dash of x. So we have to assume 0.5. So I'm just assuming the half of this two intervals. So 0.5. And if you know the 0.5 means just substitute in the formula and you will get the line of values, like I need to substitute x1 in the x2 formula, and then for x3 I'm just going to substitute x2 formula. So likewise it will go on, and just substitute the formulas here and you will get the answer. Okay, and find iterative formula. So they have given on functions here using the Raphson method, and I am just taking this as x equal to cube root of n, which is equal to x cube. Right, I am just bringing this here. So x cube minus n, which is equal to 0. So this is like a equation. So all I need to do is f of x0 and f of x1. So for finding x1, I am just substituting all the values here, and from this thing, by simplifying it, you will get the value as these two, like this. Okay, this is what the answer. And then Newton-Raphson method is used to find the root of the equation. They have given one equation. If the iterations are started from -1, then the iteration will do. So iterations started from -1 means this is what the x0. So they have given the x0 value here. Just substitute these values and you will get the answer as -1.5. Again just substitute, and you will get x3 and x4 as the same value. So stop up to this. So this is nothing but square root of two formula. Square root of two value is 1.4141, right? So it looks like minus root 2. So this is what the answer. So it converges to minus root 2. Okay. And the real roots of the equation, they have given one equation is evaluated using NR method. If the first approximation of value of x, they have given values. The end approximation of x correct to 3 decimal places. So we need to correct it to 3 decimal places. They have given the values, x values. So we have written the functions here, and we need to find the first derivative. After that, substitute the values, and we know the value is this one, right? So I'm just substituting the value, and you will get the x2 value as like this. So this is what the answer. and the recursion relation to solve x equal to e power minus x using NR method is. So they have given one functions here and we need to use NR method. F of x is this function, right? X into e power minus x. F dash of x, we have found it. And I'm just going to put xn in place of x. So you can see here this is in the form like a formula. And just multiply it and you will get cancel here and then the remaining part will be the answers. In NR method, an initial guess of n0 which is equal to 3 is made. The sequence x0, x1, x3, 2 is obtained for the functions. So they have given on functions here and we need to consider two statements and they have given only one follows, one statement follows, only two follows, both the statements are follows and neither one nor two. Okay, so what is the thing? They have given a function here. Just find f of x, f dash of x and we know that x naught value. Just substitute it and you will get the values side by side. And here 0 minus 2, again 0, it will be a number. So this is not at all converges. The only possible, the first so the first condition is, for first statement is x3 which is equal to 0. So only one follows. Next one, system of nonlinear equation. NR method can be extended to find the roots of system of nonlinear equation. Just we need to consider the two functions, f of function and g of function, which both are equal to 0. The approximation of roots. So they have given one thing here, xk plus 1 which is equal to xk plus del x. So this is what change in x. This is x plus 1 and this is x. K which is equal to 0, 1, 2, it will go on. Where del x, del y we can easily find by minus Jacobian inverse. So we need to find the Jacobian here. So for this the formula will be like with respect to x, with respect to y, with respect to x, with respect to y. Both f and g functions, right? Then the necessary and sufficient conditions for convergence is should be always less than 1. P of x, P of zk the whole power minus 1 will be less than 1. Here P will represent this P special radius. Actually this is the largest eigenvalue in the magnitude. Let us consider nth degree nomials f of x which is equal to 0, number of positive real numbers of f of x which is always less than or equal to, and the sign of changes in f of x will be equal to 0. So number of positive real roots of f of x should be less than number of changes. Okay. The number of negative real roots if f of x should be less than, this is also less than number of sign changes. Number of complete root means n minus number of positive, number of negative roots. Here they have given one question here, the polynomial, so they have given one equation they have given 4 options here. So first we need to find p of x which is equal to 0, p of minus x we will get the value. So both have different functions, so we can easily say like the formula is n minus number of positive plus number of negative. So n minus number of positive and minus number of negative, right? So minus number of negative, this is what the formula. So n into n minus, okay, n minus of the whole thing, positive and negative things. Okay, so just substitute it and you will get the complex roots. Here actually x power 5 here, x power 5, right? So what is the n here, which is nothing but 5. And then there comes a note, if alpha 1, alpha 2, alpha 3, these are the notes actually which is in the summation, the equation will be a naught, these are the coefficients. Okay, and then summation I equal to 1 to n, which is equal to, we know that minus a1 by a naught, and in this case minus 1 the whole power n into an by a naught. That's it. So it is known that two roots non-linear equation, so they have given on equations. The third root will be, so they are asking the third root. Actually we know that x lambda 1 plus lambda 2 plus lambda 3 will be equal to minus of a1 by a naught. So we have got 6 here. I just substitute here, and what is this for? They have already given the sum of the two roots, which will be 4. So by doing so we will get the third value as 2. If you can use another method actually, and this will also give 2. Okay, thank you so much for watching this video, and this is the shortest syllabus actually, so we can easily complete it with a minimum of 2 videos. One video is already completed, so only some more data are there, and it will be completed in the next videos. Thank you so much for watching this. Let's complete this engineering mathematics soon. Thank you.